I taught myself how to weld plastic after I could only find videos on YouTube that don't really count as welding. It's an ambidextrous process that requires some patience and only requires a hot workstation like this one. It's low energy enough that you can do this in your apartment. Now keep on watching as I try to learn you how to actually weld plastic. I would first like to do a glance-off overview of what we are trying to achieve structurally when welding a 3D printed part. When an object is subject to bending stress, whether it's hollow or not, the majority of the stress is concentrated in the outer layers of the object. In this case, the object is being bent downward in the center, so it is experiencing elevated compression stresses at the top surface, and tensile stresses at the bottom surface. The amount of stress in the material drops off as it moves towards the middle. This is a big reason why, when 3D printing objects, the infill percentage often has a far lower impact on what people would call overall strength than the number of shell layers. Although, this is definitely not always the case. Shear and tensile strength would definitely change with infill density, as those stresses are largely dependent on cross-sectional area. So when we are welding a 3D printed part, we are not necessarily trying to get full penetration throughout the structure, but just welding the two shell pieces into one to accommodate a load path. Ideally, we will be welding two parts together that have walls on the surfaces to be welded. In this case, the infill will already be bonded to the walls that are welded. So if shear and tensile stresses are expected on the joint, leaving in the walls when 3D printing the parts is ideal, because this will help facilitate a 100% penetration weld. In summary, our goal of welding this 3D printed part that I have is to complete the shell. The infill really isn't that important because the walls are already fused to the infill in this case. I first figured out how to weld plastic while in college, and I still have two of the projects that I had completed. The first one I have is this PlayStation controller case. I welded the hinges on because I needed the layering of the 3D printed hinges to be in a different direction than the rest of the case for strength. The second project I did was this laptop cooling pad. The print was far too large for my Creality Ender 3, so I decided to print it in pieces and practice my plastic welding. I created dovetails to help hold everything together while welding, and I also had these stiffening features to try to weld over. As you can see from these examples, the resulting weld shouldn't look too far off from a standard stick arc weld in metal. Also, we don't necessarily need a large gap between the parts to be welded. We can actually get away with some pretty makeshift ways of holding the parts in place while welding. When in college, I didn't have access to the same amount of consumer debt as I do now. My first parts were mostly held in place with these cheap, Hyper-Tough branded clamps with folded up aluminum foil in between the part and the table. It may not be the most ideal setup, but it cost less than $10 and it mostly worked. For this video, I decided to significantly step up my part holding game and get a fixture plate with some screws and washers. I got this cute little aluminum fixture plate with a grid of threaded 1/4 20 holes off eBay from CZ Industries Inc., manufactured in the USA for only $85. I have placed it on this neoprene rubber sheet that it holds it solidly in place on my table, although a silicone mat would be better due to the higher heat resistance. I got these brass 1/4 20 hex socket head screws and thick stainless steel washers off McMaster-Carr. All these pieces will be linked in the video description. I wanted to go with aluminum screws with the aluminum fixture plate to reduce the chance of accidentally stripping out the threads, but the aluminum screws were about 5 times the price of brass, and that just wasn't worth it to me. Alright, let's finish screwing around and get to welding. I printed these plates with holes in them to make my life easier in keeping these pieces in place. You really don't want much of a gap when welding plastic, largely because of the tools that are currently available. We have to pre-place and preheat our filler material, so the gap really can't be that big. Plus, we're not going for 100% penetration welds in one pass here. I'm thinking about trying to invent a proper plastic welding gun. Let me know if you think it's worth investing my time into. Now that I got the gap I want, I'm going to use some filament straight off the spool as filler material. I have also used scrap pieces like brim material as filler as well, but I don't have any at the moment. Now using the heat gun, position the filler material in place and heat it up enough so that it sticks there. For the PETG I am welding, I have my heat gun and soldering iron set to 260 degrees Celsius. Also, I put these pieces on printables if you want to save a couple minutes of time. We're almost to the fun part. Most of your heat control is actually coming from the heat gun. We have the soldering iron heated more so the plastic doesn't instantly solidify when contacting it. If we tried to do this with just the soldering iron, either the plastic would burn, or you would have to say goodbye to your loved ones like you're going on a 6-month deployment to weld plastic in the Middle East. In case you didn't get that joke, it would take a very long time and would be very frustrating. You want to use an end piece on the heat gun that most closely matches the width of the weld that you're going for. Heating up areas of plastic that are not intended to be welded can result in the infill getting too hot and collapsing, thus ruining the part. Hold the heat gun at a slight angle so that the hot air is moving towards the current weld area, but then moves in the direction of the welding movement. This will help keep the weld moving by preheating the area before the soldering iron gets to it. You may have to adjust the angle back again if more heat is needed at the current weld area. If the part starts getting too hot and starts to melt uncontrollably, move the heat gun away so that the heat being added is reduced. You will likely have to frequently adjust the heat gun position. For the soldering iron, use a tip that has a small radius, not pointed. There will be some resistance when it's moving through the plastic, so using a fine tip could result in the tip bending. You may also want to have a dedicated soldering iron tip that you don't use for anything else. For welding PETG, I typically set my heat gun and soldering iron to 260 degrees Celsius. For other materials, I would suggest starting with the manufacturer's max temp settings for 3D printing plastics. Once you have sufficiently heated the plastic, push the iron tip into the plastic. The depth of the tip penetrates into the material is your weld penetration depth. Move the tip in a helical pattern. Remember, plastic, unlike metal, is made up of long polymer chains and you are literally twisting them together. You can move as fast as your heat allows, but not so slow that you melt your part into a puddle. This will likely be a slow and tedious process that requires some practice to get right, especially if you don't have any experience with TIG and oxyacetylene welding. Ensure you are incorporating your filler material and mixing together equal parts of both pieces you are welding together. Don't forget to control your heat from the heat gun at the same time. You may need to oscillate the focus of your heat between the filler material and the part. After you're done welding the one side, stop for a minute and let the part cool. You can use a fan or some other source of cool airflow to help cool the part. After you complete one side, flip the part over and complete the others, and therefore the shell. And that's a success. You can either now marvel at your handiwork or cry and reconsider your self-worth. If you are at a latter point, just keep giving it a try until you get it down. There are a couple things that you want to try to avoid to maintain the maximum strength of the weld. You want to avoid burning the plastic in any way. This looks like discoloration in the plastic that is brown or black. I have once seen that there was an oil-looking fluid that came out of the plastic, but I was just able to wipe it away. I think it may just be a remnant from the filament manufacturing process, but you'd have to ask a material scientist/engineer to be sure. You will also want to avoid holes that may look like porosity in a normal weld. This is bad in the same way porosity is bad in a metal weld. It can lead to stress concentrations in the weld that lead to structural weld failure. You will also want to inspect other areas on the part that got too hot and have warped. This could compromise the structural integrity if that is important in that part. That warping would have likely come from the infill getting too hot and collapsing, bringing the top layer down with it. Now with that, I hope you're off to the races. Mention in the comments if you have any questions or suggestions, and share this video with those who would also like to stick together plastic without adhesive. Thank you for watching. Please consider liking, commenting, and subscribing. This isn't my day job, so I just post videos whenever I can. I included links to an Engineers Weekend Facebook and Instagram pages in the description. Thanks for sticking around.